Okay, starting out our surface area and volume chapter. We're going to first talk about what the 3D figures are. We're going to talk about cross sections and revolutions. Our warm-up is saying let's just name these two-dimensional shapes. That's all we're going to be doing right now. The first one, we see these 4 congruent tick marks as well as 90 degrees, so this is going to be a square. Your next one has 4 sides, the 90 degrees, but it does not have 4 congruent sides, so this is going to be a rectangle. I think we all know the next one's a triangle. Next, we have 5 sides. 5 is a pentagon. We then have 6 sides, hexagon. Hexagon has an X in it, so does 6. And then lastly, we have 8 sides, which I think most of us do know and remember. This is an octagon. So when we start talking about these shapes and the different properties of them, I'm going to be using a lot of highlighting just so we can kind of bring out the really important things to remember with our vocabulary. This is going to be a solid with all flat surfaces that enclose a single region of space. Is called a polyhedron. Polyhedron is like a really fancy word just to say it's a 3D figure, 3-dimensional figure. And each flat surface, so all the different flat surfaces are called the face. So I'm going to go ahead and zoom it out a little bit and show you. You can see all these little flat surfaces right here. These are all called the faces. Okay, I'm going to leave it zoomed out here because I'm going to keep bringing this back up. The line segments that intersect are going to be called edges. You can kind of see it on this diagram. It's not the best. The edges are here. Okay, where the faces are going to meet. We've got an edge here, edge here. All of these one-dimensional things are going to be your edges. So we got the line segments or edges. And the point at which 3 or more of these edges intersect is going to be a vertex. These are all the sharp corners, okay, where our angles are formed. These are all vertices. Okay, this is not a vertice, that's an edge. But right here, these sharp points, those are going to be the vertices of these. So here you go. And we got that, got it kind of pointed with that little point right there. Now we're going to talk about the difference between a prism and a pyramid right now. A prism is going to have 2 parallel congruent faces called bases. Okay, so when you have a prism here, zoom it back out, probably should just left it zoomed out. Here we got 2 congruent parallel faces, so these will be considered bases. When we're going to talk a little bit more about it on number 1 down here, but over here, we're going to talk about the triangular prism. This is one of the toughest ones to realize where the bases are. Okay, I'll just go ahead and leave it zoomed. So your prism, 2 parallel congruent faces that are these bases. Okay, and it's showing you on this pentagonal prism. Now your pyramid is going to be a polyhedron or a 3D figure that has only 1 polygon base. Okay, so if we look at a pyramid, you see in the picture here, but that's the base right there. Okay, and your 3 or more triangular faces that are going to meet at a common vertex. So the base is going to be how we're going to name it, and then the other faces of a pyramid, as you can see, will always be triangles. With your prism, you're going to have your faces that are not the bases are going to be parallelograms, and in our class, rectangles. Okay. Now we're going to go ahead and we're going to see that a polyhedron or 3D figure is first named by the shape of the base, and then we have to determine, are the rest of the faces rectangles or parallelograms, or are the other faces triangles? And that will tell us whether we put prism or pyramid. So we take a look at number 1. This is where we have to be careful, especially the first one here. The triangular prism. I'm going to go ahead and tell you what it is. It's a triangular prism. This is the hardest one for students to understand where the bases are, especially when we get into volume and surface area. We have to know which one's the base, because with your 3-dimensional figures, the base is not always what it sits on. This is extremely important. It does not always sit on the base, and that's what's happening in this first diagram. Okay, we're going to go ahead and shade the base. The bases of this are in the shape of a triangle. Notice that the triangles are parallel. That means those are the bases, and it is a prism, because the rest of the sides here, the rest of the faces are rectangles, so we have your triangular prism. We take a look at the next problem here, the next picture here. We have all parallelograms. Every single face is a parallelogram. When we have this, we already have automatically a rectangular prism. And we can look at any of two parallel sides as your base with a rectangular prism. We'll go ahead and shape that one. See if I can spell right. There we go. Next, I'm seeing a bunch of rectangles, a bunch of parallelograms wrapping around, and then I'm going to see this pentagon, and on the opposite side, parallel to it, is another pentagon. So this is going to be how we're going to name it, as a pentagonal, and then we see the rectangles, or the parallelograms, on the other faces saying it's a prism. The next diagram are all triangles. Every single thing is a triangle on this one. So because we have this sharp point at the top, we're going to have a pyramid. So we have all of our faces are triangles. And here at the base is also a triangle. All triangles, triangular pyramid. The next one, I'm going to see this vertex up here, that sharp point. You don't want to run and fall on that, okay? That's going to tell you, here we have all these different triangular faces giving us a pyramid. And if we look at the one that's not, the one face that's not a triangle, that's going to be our base here, which is going to be a square or a rectangle. Now we can't, I think it's got these, let me see, make sure I didn't write that. It has these little tiny tick marks here, which I think are supposed to tell us that all four sides are congruent, because I did see a right angle right here. So we'll just go ahead and call this a square pyramid. The last one, we have that sharp vertex we don't want to fall on. Okay, so we have a pyramid with all these different triangular faces. We look at the one face that's not the triangle, and that's going to be the base. And this is going to be five-sided, so it's going to be a pentagonal pyramid. Have circular faces instead of these polygons, because a circle is not a polygon. A cylinder is going to be a solid that has two congruent circular bases, or bases that are circles. And my cylinder's a little big, so I couldn't find a smaller one, but here we've got the two circles, and then we're going to have one circular curved face that goes around. Okay, put that back down a little bit closer. And then with the cone, sorry for all the wiggling around, hope you're not getting nauseous and seasick. Your cone is going to have one circular base right here, and then it's going to have a curved surface, but it's going to have a vertex this time, okay, just like with our pyramids. And then your sphere is just going to be a round ball, right? It's got no edges, it has no faces, etc. Get all my shapes organized. Now let's take a look at what's called cross sections. I'm going to do the best I can on the video with my solids that I have to represent the cross sections. A cross section is an intersection of a solid and a plane. Remember that a plane is a two-dimensional flat surface. It's like cutting something, just cutting straight through. The shape of the cross section formed by the intersection of a plane and three-dimensional figure depends on the angle of the plane. So when we talk about these down here, we're going to go ahead and sketch what it looks like, and we're going to go ahead and identify what this cross section looks like. Here we have a direct horizontal cut of a square pyramid. When we have a direct horizontal cut, what's going to end up happening is when we cut here, if you look down from the top, what shape do you have? We have a square. So when you have a direct horizontal, you can look at the very top and see what shape. And so we'll go ahead and draw in the best we can of what looks like a square. Now the second one, we are not going directly horizontal. We're going to go ahead and cut it kind of at an angle. The more of an angle you go at, the more these four sides are not going to be the same. It's going to turn into a rectangle instead of a square. Usually the cross sections we talk about are going to be direct horizontal or direct vertical. But here we can just kind of sketch a little rectangle. And then the vertical cut, straight up and down, if you lay the pyramid like so, okay, I'm not laying it completely flat, I kind of have it raised up, what shape do you see? We see a triangle. These are they can be relatively hard to see sometimes. You have to actually visualize this, okay? Now with the this next section, we've got four different solids here. And I'll let you know right now, my hemisphere solid is way too big to put underneath this camera, okay? But for all of these, we're going to be looking at the horizontal cross-section and the vertical cross-section. When we look at a horizontal cross-section, we're going to be cutting like this. Like I said earlier, if you're going horizontal, lay it flat on its base and look straight down from the very top. The horizontal cross-section is going to be the exact same shape as the base. In this case, a hemisphere does have a circular base. So we'd have a circle here. If we go vertically straight up and down, you need to turn it to the side, like what I did with the pyramid, turn it to the side, and exactly right here, obviously here we'd have that triangle we discussed up above, but with a with the hemisphere, you're going to have a semicircle. With the cone, if we look at this horizontally, okay, I've got a little cone here. We look straight down from the very, very top, what do we see? We see a circle. Okay, here's the vertex way up here. Look straight down, we see a circle. If you look at it vertically, right here, what shape do we see? We're going to see a triangle. The cylinder, okay, if we look at this horizontally, look straight from the top. Just kind of zoom that out a little bit more. Straight from the top, cutting it straight horizontally, we're going to have a circle. And then if we look at it vertically, lay it on its side and look, and what do we see here? Almost got the whole thing in here. What we see here is we're going to end up with a rectangle, okay? Sorry, this is the best way I can show representing the cross sections with my three-dimensional figures. I don't have any really cool toys that show cutting it in half. But this right here would give us a rectangle. With the triangular prism, we cut it horizontally. Again, horizontally is always going to be the shape of that base. So when we have the prism laying like this, okay, that's the way it's looking. We look straight down, we're going to end up seeing a triangle. The triangular prism gets a little confusing sometimes with this horizontal view right here. But when you look at it horizontally, lay it down like this, you're going to end up with a rectangle, vertically, when you cut it vertically, because the faces around that connect your two bases are rectangles, therefore the vertical cross section will be a rectangle as well. So again, with these, it's kind of, you're really going to have to visually see this, and that way it's a little bit easier. But every single time, if you do a horizontal cross section, look straight down from the top. What is the shape of the base? The last thing we're going to talk about are revolutions. Okay, solid of revolution is a three-dimensional figure obtained by rotating a plane figure. Okay, so right here, here's this line. We've got this triangle, and we're going to curve it around. So we're going to be going around this line. And you can see the start of the rotation, we're starting to see a base form right here. And we're seeing, okay, it keeps going around, keeps going around, keeps going around, and we're going to wind up at a solid. Now, with the revolutions, I will let you know right now, you're always going to have a three-dimensional shape that's going to have a curved face of some sort, a cylinder, a hemisphere, a sphere, a cone. That's what we're going to wind up with. We're never going to wind up with a prism or a pyramid because those don't have the curved faces. So we're going to go ahead and identify what's happening with these. If you take this rectangle and you rotate it all the way around, it's kind of hard to see with my hand, but you rotate it all the way around, you're going to wind up with a cylinder. You're going to have a circle on both ends. With B, you're going to rotate it all the way around, okay, and it's going to end up being a sphere. And then this, with a triangle rotating all the way around, it's going to be a cone. I'm not doing a lot of visual representations of this. The best thing to remember is, what shape is this? What does it begin as? What will it automatically be? A square or a rectangle revolution will always become a cylinder. A semicircle revolution will always be a sphere. And a triangular revolution will always be a cone. Okay, so if you remember those, you don't necessarily have to see visually that representation. So we're going to get some points. We're going to go ahead and graph these. And what we're going to do is we're going to figure out, hey, what kind of shape do we have? Therefore, we can match it up. Rectangle with a cylinder, cone with a triangle with a cone. And we're not going to end up with a semicircle on the graph because we're going to be putting points and connecting segments. So let's go ahead and look at number 5A. We're going to go ahead and put these vertices, these points on the graph, and as the vertices, we're going to connect them, and then we're going to draw in the line of x equals 5, because that's the line it's going to rotate around. So go ahead and pause the video and put these points on the graph. So we're going to find ourselves with a triangle. Now we want to rotate around line x equals 5. So the line is going to cross where x equals 5. So we go to x equals 5 right here, and we want that line to go through right here. And if we go at what I said earlier, a triangle revolution will always become a cone. All right, we're going to go ahead and plot these 4 coordinates. And if you remember what I said above, you may already know what shape this is going to be and what 3-dimensional shape it's going to become. Go ahead and pause the video and put the points on the graph and connect them. Okay, doing the best I can with straight lines. And then I went ahead and drew in y equals -x so we could see what it's going to be rotating around. And as we discussed above, anytime we have a rectangle rotating, it's going to end up being a cylinder. Hopefully the visuals were okay with the solids and everything made sense. Please go back, rewatch anything, or ask your teachers if you have any questions.